Hello,
Okay. Action. Okay.
there we go. Hello, everybody. That was a false start, but yeah, John's still doing the drum roll. I'm going to be speaking about the gas station network, which is a very exciting project that was originally started by Open Zeppelin, and I've always been a fan of the work Open Zeppelin have done. But it's a framework to easily integrate meta transactions into your application. And this idea isn't brand new or anything. It's been around, I think, early 2008. People started really thinking about it and talking about it. And there have been various attempts at frameworks. But the gas station network in particular is probably the most established. And as I say, Open Zeppelin are an extremely good company. So I really trust their work. Trying to implement this yourself or do it in an ad hoc way definitely isn't wise. I personally have found it actually very complicated to try and integrate because we want to use this for wildcards and some of our other projects. And I've been running into a lot of problems. So there won't be a demo today, unfortunately. So that's the sad news. I honestly think I was this close to getting a demo ready. But yeah, no demo. It's also not going to be a tutorial. So I'm not going to be writing code. I'm not going to be showing you what code to run. This is just going to be very conceptual. And I'm actually going to go through the gas station network docs themselves. I thought about making slides and stuff, but their docs are really good. And if anyone else who's watching wants to integrate the gas station network, going through their docs will be super useful for you too. So yeah, I'm not going to read the docs, but they are going to be our guide. So if you could share my screen, Dana. Okay. Go for it, John.
I was going to ask if these docs, if you can give a bit more of a high-level overview again of why people might use gas station network and what including meta transactions, etc. means.
Yeah.
It's still pretty up in the air.
Yeah. I just realized there's another tab that I wanted to have open that isn't open, but we'll get there later. So basically, for normal Ethereum transactions, when I say normal, I mean all transactions before people thought of using meta transactions. The person sending the transaction has to pay the gas, and the person sending the transaction is like the agent in the transaction, right? And that's great. It's simple. The user's private key signs the message. It gets submitted to the Ethereum network and it gets processed. The downside of that is that that user needs to pay in ETH to make that transaction. And that's fine if the user has ETH, but it's quite a big expectation when you're building an application that your user has ETH, especially if when they're using the application, they do not actually use ETH, right? Let's say they're doing everything in DAI, which is a stable coin, or another type of token that's native to that, whatever app it is. And gas station network and meta transactions in general allow you to abstract this, right? So here we go. In the top example, the user needs ETH to pay for gas and sends that to Ethereum. Whereas if you integrate the gas station network, the user doesn't have ETH. They send it to the gas station network. Someone else pays for the transaction. Then the pay master contract refunds that person that paid, normally with a fee. And then the contract at the end executes. And obviously this contract needs to know about the gas station network, because by default, this user is the person who signed the transaction. And if someone else sent the transaction, then the contract needs to understand that and manage that. So we're going to go through that. These 4 points are great, so let's go through them. Example use cases. You can pay gas in any token. So let's say we are building something for wildcards. We've got the wildcards loyalty token. It's got a value, and we want to allow users to pay for gas using the wildcards token and not using ETH. And how that would work is our server would take a message that the user has signed, format it and whatever, and then send the transaction on behalf of that user. So our backend server would pay that gas in ETH, so we'd have to have ETH. Then the paymaster contract would take ETH from the user and refund us as the server in wildcards tokens. So that's the fee for the transaction, and then the transaction would happen. So the user there never needs to use ETH, which is very cool.
Ask a question.
Please.
Does the paying gas in any other token, is that a little bit like how Argent does it?
Mm-hmm.
And does Argent have its own relay system, or does it use gas station network?
Yes, that's a very, very good example. So if anyone has used Argent, they use meta transactions, right? That's how they abstract paying for gas. So your identity on Argent is a smart contract that they deploy for you. And then they submit transactions via their relayer network, where they abstract the gas. On Argent, I'm not 100% sure if you can pay gas in DAI and other tokens.
Yeah, you can.
You can. It would make sense if you could, but I didn't know that feature. But no, they do not use the gas station network. That's
their own relay system.
yeah, but it's very similar in a lot of ways. The gas station network is primarily for dApps. So each dApp will make their interface gas station network aware. And once your dApp is gas station network aware, then users can use the gas station network to interact with your dApp. So it's quite cool. It's like a global thing. And as long as all of these contracts have the correct interfaces, they can integrate with the gas station network. There's a whole bunch of gotchas and complications there. So let's not go into that. Number 2, pay gas in fiat. I mean, that's quite cool. Let's say the user pays with a credit card or something else. Then privacy. Yes, this is another example where someone has used meta transactions. The Tornado Cash system is about privacy, and if you sign the transaction to withdraw your funds from the Tornado Cash network, which is a way of anonymously transferring ETH and DAI, and I think maybe some other assets. If you had to sign that transaction yourself, that would be giving away your identity, right? So how that works is they have a relayer system. It's not the gas station network, but similar, where you ask someone else to fetch your token for you. You give them some kind of secret key that unlocks the money, and then they take a fee from that. So let's say you're withdrawing 1 ETH from Tornado Cash, they'll take 0.1 ETH as a fee, as a payment for doing that. And then, lastly, user onboarding, right? So new users want to just come on and use your app and not have to worry about all of the complications I've been speaking about. So that's great. I think we've spoken a lot about the problem. Let's move on to the architecture. So I'll go through all of these components. This architecture is specifically for ETH gas station version 2, right? Last year they released a much simpler version that only really had one or two contracts in it. Enlarge, thank you. I can make it one step bigger. There we go. So how this works, let's go through the numbers. So when they talk about the client here, they mean like the person using the dApp. So it can be a website or a phone app or even a backend service, let's say Argent or something like that. The client then sends the transaction to the provider, like what they want to do in the transaction, but that provider then doesn't sign it and submit it directly to Ethereum. That's what normally would happen. It sends it to a relay server. The relay server then takes the user's signature, so the user signs that message first and turns that into a transaction where they would pay the gas. That they verify on chain that everything would work and that they do some checks. Basically, that's what step 3 is. Then step 4, they send back the meta transaction to the client, so the client can see, cool, someone's going to submit it for me, and they know the information about the transaction. Then the relay server actually submits that transaction to the Relay Hub contract. We'll definitely speak more about that contract, but in theory, there can be one Relay Hub contract for the whole of Ethereum, and lots of people use this contract. It's like it's a hub. That's what the name means. Then number 6, it goes to the trusted forwarder contract. Once again, we'll deep dive into that, and only then does that get sent to the recipient contract. The recipient contract then receives the signature that it got and the nonce, and it basically gets the message.sender who signed it. So they use the signature, decode it, and get that. And then the transaction executes, and over here, the paymaster manages payment. So the whole system is very modular. You can add different logic in the trusted forwarder. You can add different logic in the paymaster, etc. So let's go through this one at a time. As I say, the client is where the transaction gets signed and sent, but it gets sent to the relay server. It doesn't get sent to the Ethereum network. Then the relay, as I say, anyone can deploy another relay server, like it's kind of a utility, but in theory, there can be one relay server for lots of people to share. Lots of relay servers that people share. That's why they're saying all for one and one for all and all for one. They do recommend that if you have a dApp, you should also run your own relay server. And the thing is, when you run a relay server, you should be able to make some fees on that. So every transaction you submit for another dApp, you can charge a small fee, which is cool. This is not to be confused with the contracts. This is not the Relay Hub. This is actually like something running on AWS or wherever it's running, right? Then the paymaster basically agrees to refund the relay server for the gas. So the relay server has to pay in ETH, like I mentioned before. But then the paymaster can have a different deal where it pays the relayer back in DAI or Wildcards community tokens, or it takes money from the user that submitted the transaction or whatever. You can have all sorts of custom logic in here. The trusted forwarder basically allows you to keep everything very modular. So one of the downsides, if I understood correctly, from ETH Gas Station version 1 is that when people integrated it, it added a lot of complexity to their own contracts. And that's bad because then the auditor has to check the integration with gas station network and understand that interaction. Whereas if you use a trusted forwarder, you can basically stop bad or malicious calls over here, right? So it doesn't go past this point if someone's trying to hack you. And inside your contract, all you need to know is the message, the underscore message sender, which, yeah, is easy to verify. And what you do is make sure that this contract can only receive messages from your trusted forwarder, so that there's a separation there, and you can audit this independently. Then the recipient contract, like I said, basically you stop using message.sender and use this new function that you'll inherit when you when you build this up. I'll give you some example code. And then lastly, there's this relay hub, which has, hopefully, hopefully the network you're using already has a relay hub deployed to it. We, for wildcards, are using Matic, and Matic actually don't. So we have to set that up ourselves. But hopefully in the future, there'll be like a common version that's maintained for everyone. And that's the main overview on the contract. So let me come here and check. So I've created this base, and you can see here the message.sender function, right? Which essentially checks that the message 1 comes from the trusted forwarder. Remember what I was saying over here. This contract, you make it so that only this contract can send the calls, and in that way you reduce the complexity in your dApps logic and keep the complexity of all the meta transaction outside. And this basically returns an address, doing some cryptography inside. And then similarly, you can get the message data if you need that in your contract. And then this interface over here actually gives you quite a bit of flexibility. So over here, we're not doing anything with a pre-relayed call and post-relayed call, but effectively you can add some additional logic before the relayed call and after the relayed call, and pass around context to keep track of things. So let's say you want to use some different type of token here or something like that. But yeah, for the most part, this is the important one. And these are all of the parameters, that we get. And once we've got that, then to integrate this into your code, you just inherit from it, right? And once you inherit from it, you basically convert this contract into a gas station network recipient contract, and this contract can be executed via the gas station network. So yeah, maybe if there's any questions, this is a good time to pause. Nope. Cool.
All good.
So the last sort of puzzle, step in the puzzle, is to actually integrate this into your sort of code, your JavaScript code. So let's go here. There's some example code. Essentially, you wrap your provider into this thing called a relay provider, and then from there on, it's basically the
Pretty
same.
standard. Yeah.
So yeah, I can show you. Oops, I can show you how I did it in this code. Sorry, this is very messy. Like I was saying, I haven't gotten this all to work 100%. But yeah, you get the gas station network library, you get this relay provider, you get this function that configures it, you add the config, so you add the relayer hub contract address, the paymaster address, the stake manager address, etc. And then you wrap your other provider in the gas station network provider. And then because I'm using Ethers.js, you create a new provider from this provider. And then, yeah, I'm using the signer from that provider. And in theory, this all should work. But in practice, it's quite fiddly. And I've obviously done something wrong in all the configuration. So yeah, that's the high-level overview. When you come here, for example, you can see all of these sort of default implementations that you can use. Gas station network version 2, and then, yeah, obviously gas station network version 1 over here. Yeah, how are we doing for time? Very good for time.
20 minutes.
Yeah,
I'm worried
but
that
we
there's
can
no
discuss it a bit
question.
more now.
I'm worried that there's no question.
Yeah,
Meant
I
to be
think-
complicated.
So Jason,
Yep.
no, it's not. If I had to say it in complete layman's terms, let's just say, like, so my mom could understand sort of the whole purpose as such, to a large extent, that like a bank charge, instead of the person who's initiating the transaction paying a fee, the person who's sort of receiving could pay the fee, and that network fee could be abstracted to different people based on different use cases, allowing wildcards to basically say, we'll pay for your gas to adopt an animal and that type of thing. Super simply.
That's
Oversimplification, but that's
and
what
what's
it is.
quite cool is this paymaster can do all sorts of wild things, right? You can put custom stuff in there. You could make it so that someone can
contract
pay with NFTs. They can pay with CryptoKitties, or they can, I don't know, do another favor for you, or I don't know what.
So network only pays if it's sunny outside, whatever.
Yeah, literally. So there's a lot of scope for customization. It's pretty scary, to be honest, because it feels like you might make a mistake very easily and just allow someone to steal all your money. Yeah, I should mention.
I was going to say, that's what happened on that gas attack, right? When they hacked the exchange, and they couldn't per se get the money, but they could alter the gas price for the transaction, and they set the gas price to like $1 million Gwei or whatever, and like spent $150,000 of the people's capital on gas. There's all kinds of weird things.
I should look that up again, because I do
I thought that's what happened. Yeah. People were saying, is it a way to launder money?
I don't know.
From what I remember, that's what happened in the end. It was like an attack.
Yeah, I don't know if that's what happened or that's what people were speculating could have happened, but yeah, for sure. So yeah, let's actually talk about that. The paymaster here, actually controls which transactions it accepts, which like things it accepts, right? And that's really important. So let's say this paymaster, I deployed a paymaster, and it was a very bad Paymaster. I think there's some examples here. Paymasters. So this Paymaster could just it'll submit transactions for anyone. It'll pay for anyone, right? Here we go. The accept everything Paymaster, right? That's not going to be nice on mainnet when I can ask the Paymaster to do my Uniswap for me and get a free transaction and make the Paymaster pay $20, right? So this Paymaster, you need to implement security. And here are a whole bunch of examples. The whitelist is very simple. The whitelist just means the Paymaster checks who the recipient contract is, and it'll only allow transactions that go to wildcards. The whitelist Paymaster still has problems, right? So let's say we've got $10 in our Paymaster to pay for gas, or to pay back relayers when they submit the transaction. But someone could then send 100 spammy transactions as like an attack on us to the correct address, the address that's on the whitelist, and use up all of the funds that we have in our Paymaster. So yeah, that's quite bad. There's things where you can have an identity. There's like all sorts of things. You could even have verify a signature from your backend, right? And this one's quite interesting. So here they've added like a kind of proof of work. I didn't dig into the code here, but there's a pre-relayed call check. Remember, you can add logic here. In my code, where is it? In my code, it's empty, but there's a pre-relayed call and a post-relayed call where you can run some checks to determine, if you want to go through with the transaction. But over here, they do some kind of check to check if they've done enough hashing. If they've done enough sort of proof of work. So here's the sort of difficulty level, and they do a bit shift on the amount of difficulty. I feel like I'm not explaining this well, but yeah, basically it's proof of work. So if you want to send a transaction to this Paymaster, you have to do some work, and it validates that you've done some work. So it's hard to spam it. That's the theory of it. Not very practical, of course. Just as an illustration. Any more questions? Should I go deeper? Should I talk about?
I kind of have a question, but it's maybe a bit simple because I think I lost you quite early on. So it's like a re-explanation question. If nobody else is bothered by one of those, then I'll go ahead and ask it. So like, I get the basic idea, that you want people to be able to pay in something other than ETH, pay gas in something other than ETH for whatever transaction the dApp is doing. So I get that, but I don't understand the exact problem that this V2 is solving. Like, what could you maybe say what a naive solution is and why that's bad? And then after that, could you maybe go through why? We'll go through the exact architecture again and explain why it solves the problems of the naive solution, but maybe with the example of wildcards so that it's clear like who owns which contract and what is on Ethereum and what is not. Like what is some separate server? I just didn't quite follow all of that.
Perfect. So the naive solution really would be to not use the gas station network at all, be a smart ass and say, I'll just implement it directly in my contract, right? So then you have all this, you add a whole bunch of extra functions inside your code to get the message sender and to like manage calling. Let's say you want to call the mint transaction, right? You'll have something in here that can accept a meta transaction and decode it and do the mint for the user and validate the signatures and stuff. And that's totally fine. The risk, though, the first problem is you making your contract much more complicated. And even on very simple contracts, it's very difficult to be very confident that there's no bugs or vulnerabilities or mistakes that you've made. So adding more complexity to your contract is a bad idea. So that's one reason to definitely go with the gas station network rather than try and make your own solution, is because they've got a team that are highly focused on this, and they've got lots of audits, and a lot of really big high-value projects are using the gas station network. To be honest, I actually don't know which projects are using it, but I mean, this is the biggest provider of meta transactions. I think there might be other implementations. Then the difference between version 1 and version 2, I didn't do a deep dive into version 1, but the version 1 was much simpler. So they didn't have, like here we've got 4 different contracts, right, involved, whereas version 1 just had the recipient and then the hub. The hub would communicate directly with the recipient. And that meant there was less flexibility, like all those things I was saying with the paymaster, where you can implement your own like logic of like, we'll only pay for this transaction if they've done proof of work or whatever logic you have. It was less flexible on that sense. The other thing is this is what I understood reading their example. It was a less clean implementation. So with this implementation, you've got this thing called the trusted forwarder, which is just an address. And then you've got this function is trusted forwarder, right? And this whole recipient will revert the transaction if the person sending the transaction isn't the trusted forwarder, which means this code, let's say the wildcards, Stuart, and all of this logic, doesn't need to audit the gas station network's code. Like there's a clean separation, right? So you obviously have to audit the gas station network code and the forwarder code and all of that code, but there's a very clean separation. I hope that's answering the question.
Not really, it just kind of confused me more. I have a few questions on what you said though. The first naive solution that you mentioned, you went to some contracts, you went to some wildcards contract. Okay. Now, is that the recipient contract, or is that like some totally separate contract to anything that's part of wildcards, and you have to make this in order to accept like gas fees, not gas fees, but gas payment in different tokens?
Yeah.
Okay, cool. Sure. So that's fine. That answers that. Why are you minting stuff? Why is there a mint function?
Oh, that's an ERC20. Like this is code from us. So this is the loyalty token.
I see. So the client is buying something and you minting it. That's the action that is being taken.
Yeah. Sorry, the mint has nothing to do with it. It could be any function.
Okay, I understand now. No, I understand. I thought it was maybe part of the. Okay.
The thing is, it's very simple. All I do to convert this into a gas station recipient is like basically inherit from here and then use underscore message sender everywhere, instead of like normally in Solidity you write message.sender. But this is the person who signed this is the contract or address that sent the transaction here. But when you're using meta transactions, this is wrong because the user doesn't send the transaction. So you have to use this.
Sean, can I abstract up a little bit and give you kind of a practical use case on how wildcards, or why we're using this for wildcards? So currently we can agree right now to pay gas fees for someone else is very expensive. So depending on your context, for us to do on mainnet, we can't cover those gas fees. It's really expensive. But if we launch onto the Matic network, where the token to pay gas is called Matic, that price of making a transaction is very small. So we don't mind paying for that token price for that gas cost, okay? But now, in order for someone to buy a wildcard, they'd have to have both DAI, which is going to be the new kind of currency to purchase wildcards, and have Matic token. When in this scenario, we can say, okay, well, you don't actually need to have Matic token as well. We'll pay the gas. All you need to do is have the one currency to purchase the token. Does that make sense?
Yeah, that does make sense.
Really like high level why we do it without the complexity.
So question on that. In order to accept payments, like maybe you can do this differently, but my understanding is that fundamentally you must have like a pool of something, right? You can't be going through an exchange every time in your contract to swap these tokens. So really? So when someone pays in DAI, when you need a Matic token for gas, the contract is going to go to some exchange and swap that DAI for Matic so that there is Matic to pay gas. Surely you just would have a pool of Matic.
I'm not saying they have to do that. I'm saying they can do that. So, so like when I say you can implement whatever logic you want in Paymaster, you literally can, like, you can write anything, right? So you could make the Paymaster, I don't know, go to Uniswap and do some trading and convert your DAI into ETH and, I don't know, do arbitrage. No, I'm kidding. That would be a bad idea.
Take a flash loan, exploit some currency pairs, make some cash, self-fund.
But basically, as long as the relay server is happy that the Paymaster will pay the relay server back, like refund him, the relay server is happy. And what the Paymaster does, the relay server doesn't really care. And then going a little bit back, we could make a Paymaster for our Matic integration that doesn't do anything with the user, right? So then we pay 100% for the gas, which we probably will do because the gas prices, the gas transaction costs on Matic are extremely low. Like users can do a few thousand transactions for $1. So wildcards can then take that cost. We don't mind, and abstract all of the complexity away from the user. So the user doesn't have to know what Matic is. They don't have to know anything. They just go with a fiat on-ramp, get DAI, and interact with wildcards. So that's the end goal. There's quite a lot of complexity to get there, unfortunately, but hopefully well worth it. Then you had another question, Sean, that I don't think I answered very well. So these with the dark border are all contracts. I don't know what the color coding is, access accounting, but this contract, there'll be one deployed for the whole system. I mean, you don't need lots of relay hubs. It's a hub for lots of people to use. Then the trusted forwarder, you can add custom logic in here. So wildcards might have their own trusted forwarder that we add a little bit of extra magic to. And then we also might have our own Paymaster contract. Then this part, and then of course this is also a contract with the dark border. Then this part is running, let's say, on AWS somewhere. We can run our own, or we can use a third party, and that third party obviously will only do it if they're happy that they'll get paid back. So they're not going to do it for free. They'll want to charge a little bit of a fee for that service. And then the client and the provider are running, let's say, in wildcards in the wildcards website. So the provider provides the connection to Ethereum.
Right, that makes sense. So like as a very basic implementation to of Paymaster contract, could I just have this massive bank ready of ETH? So if we're moving off thematic networks, we're on mainnet. It's a bunch of ETH that is there. I can add more if I want, like the controlling party or whatever, but it accepts a certain token as payment, and then it provides ETH in exchange because you need to pay gas and ETH. Would that be a legit implementation of the payment master?
Yeah, sure. I mean, as I say, it's totally customizable.
Yeah, but I'm just trying to understand if my idea of the payment master is correct. So I just want to see if that very simple implementation is a payment master. Now, why would you not just have a payment master in the recipient contract? Why can't the dApp say, Mr. Payment Master, can you exchange this for me or whatever? Like, this is the token that the client wants to pay with. Give me some stuff that I can actually pay with, which would be ETH, and then pass that on to the recipient contracts.
Yeah, you could. So yeah, that's totally possible. This contract could be one, like the purple and orange yellow thing. They could be a single contract, right? And then at this step, this arrow calls the recipient contract and does the payment, right? The reason to separate it is just to keep complexity apart. Some poor auditor has to go through all this code and make sure there are no bugs and whatever. And if one contract starts getting huge with many thousands of lines of code, it's just not fun to look at. So that's why they're separate. Was that your question?
Yeah, that answers my question. So now, can you, like the rest of the stuff, the Meta Relay server, the Relay Hub contract, and the Trusted Forwarder contract, can you add those to the system we were just talking about, the simple system? Can you add those in pieces, or do you have to add those all at once? Do you know what I mean? Like, does it, in the simple system where you have a recipient contract and a paymaster contract, can you add a trusted forwarder contract to improve the security of the system or better the system?
Yes.
Or does it only make sense to add all the other ones in one piece at once?
So if you're going to use gas station network, you do have to comply with the gas station network like interface. But in theory, this recipient contract could include the paymaster and the trusted forwarder, right? And then all it does is it goes to the Relay Hub, and then it just interacts with your contract. But it's the exact same reason that I said earlier. You want to keep your contract modular so that each contract alone is less complex, and you isolate your complexity so that it's easier to review. So the trusted forwarder contract only does one thing, and it does it well. It validates that the thing that it's getting is correct, like it's got the correct nonce and I don't know whatever other stuff. And then this contract, all it has to do is say, hey, is it from the trusted forwarder? Yes. I trust that trusted forwarder because I know the logic in that trusted forwarder is good. Therefore, this contract is much simpler. I want to quickly show you. So this is kind of a meta transaction. They do have a link somewhere to the contracts, how it works. Yeah, here we go. So DAI, the multi. Yeah, sure. Actually, I don't need to go to the code. It's right in front of me. So this is built into multi-collateral DAI. So that's basically DAI version 2. And it's a very cool function. It's actually not a standard. So not a lot of other ERC20 tokens have this. But what it allows is someone else to spend die on behalf of someone else as long as they have the signature. So this V, R, and S are the standard components of a Ethereum signature. So this is an elliptic curve signature. So yeah, where the magnifying glass is moving. Then you've got all of these other parameters. Holder, spender. So the holder is the person who has the DAI. The spender is the entity that you're giving permission to spend the DAI. The nonces are just very important so that you can't replay transactions and things like that. So yeah, it's just for security, and kind of ignore it if that didn't make sense. Then the expiry is like a date that you're happy to let that other, the date that the holder is going to allow the spender to do this, right? And then the allowed is, I actually don't know what this Boolean's for. I guess, I don't know why you'd ever make this false, to be honest. But yeah, so what this allows is basically me to spend DAI. So let's say wildcards can spend the user's DAI without the user actively approving and sending it first, which is, yeah, really cool. So yeah, this is a meta transaction. This permit function uses a kind of meta transaction, and it's built in, and it's pretty simple. It doesn't have all of this complex stuff, but it's also not general purpose, right? This is, this permit basically can only, it can only be used for one very specific thing, which is giving the user an allowance. So yeah, here you can see if this is set to true, it allows the contract to spend as much of the user's DAI as they want. So -1 of a unsigned integer is actually the largest possible integer. So it's a really, really big number. I feel like I'm rambling, so I think let's either wrap it up or go for some more questions.
I could do some more questions, but I don't want to bore everyone just because I don't
know.
understand.
No, go for it.
Can we go back to
doing?
Can we go back to that architecture diagram?
We got a meeting in a few minutes, so let's do one or two more questions.
Just tell me when it's just interrupt me when you gotta go. Can you bring up that architecture diagram?
Sorry, I missed the question.
That architecture diagram. Can you display that again?
Denim, can you share my screen?
Sure.
Cool. Zoom in a little bit more. Ah, that's good. That's really big.
Can you speak a little bit high level-y about why I don't just have the client provider payment contract and recipient contract? Like why is there other stuff there? What does it give the system?
So that's the norm. Like if we don't use the gas station network, that's what it is. So the user has let's say their phone has MetaMask wallet or something installed on it, and that's the client. And MetaMask has built in a provider, so that's how MetaMask works. And then they send the transaction to your contract. So that's the started line. So I'm trying to hide the other stuff. So like this is the typical flow, right? But it requires that the user has gas. It requires that the user, let's say they want to be anonymous.
That's not really my question. I'm saying if we can have that the user doesn't need the specific currency for gas in order to pay gas, because you can have the payment contract separate from everything else. You can have the paymaster contract, So you have the paymaster contract, the recipient contract, then you have a system where the client can pay in whatever token they want, right?
Yeah, or the
So
company can pay for them, or
yes.
anything else that you need.
What does the gas network give? What is good about the system?
Because if I were to write all of this code and implement it myself, firstly, it would probably have vulnerabilities, and two, it would take a lot of time. So the gas station network has all of this out the box. As I say, it's still complicated, and I still haven't gotten it to work properly. But in theory, it's quicker. The other thing is that it's still decentralized in a way. So in theory, there should be hundreds of these relay servers all around the world, right? And as long as the wildcards contract, for example, is using the gas station networks like interface, anyone can, let's say the wildcards relay server goes down, like it crashes, I pressed the wrong button on AWS and it's deleted, right? It would really suck for users if they couldn't use wildcards because of that. So using the gas station network means that there's other infrastructure and it's more decentralized.
Wait, it's not really what I'm asking about.
You're asking why use this?
No. So like the paymaster contract, do you have to write one of those?
You can use a default implementation, right?
Okay, cool. So let's say we just grab
Gas Paymaster. You can come to this website, copy paste this, and then you've got like a weird proof of work thing, or you can use the whitelist one.
Yeah. The thing that I don't understand is why you need servers, right? Because in the simple example where all you have is the application, right, the DApp, the payment, the paymaster contract, and the recipient contract, we have a complete system that will allow clients to pay gas in different currencies than what the gas is usually paid in. Now, what I don't understand, whether it's the gas network or whether you implement this network by yourself, whatever, I don't understand why there are servers, why there is a relay hub contract, and why there is that trusted forwarder contract. Like, what is the vulnerability in the system of the very simple provider, paymaster, recipient that is solved by having those three extra things: the servers, the relay hub contract, and the trusted forwarder contracts?
Okay, so maybe taking a step back, I feel like some of this maybe you already understand, but if you don't understand it, then I'll understand your confusion. So firstly, the relay servers that are running on I don't know, some cloud machine, AWS or Google Cloud or whatever, it doesn't matter. They submit real Ethereum transactions that use Ether as gas, right? So that's why they exist. Someone somewhere has to submit a real transaction and pay the gas, because Ethereum, you can abstract gas costs from the user, but ultimately Ethereum runs with Ether as gas. So that was your first thing. Like, why do we need this? Is that cool with you?
Yeah, I think what I was confused about is the fact that the paymaster contract could pay gas.
So I thought
the browser could submit a transaction to the paymaster contract, and the paymaster contract just does this switcheroo and calls the recipient contract with the correct gas.
So the paymaster contract is responsible for repaying this relay server. But let's say for wildcards, we want to pay for the user's transactions and we don't care about the users paying us or whatever. Then we could have a very stupid paymaster that doesn't pay us back. So our server submits the transaction, pays the transaction in ETH, and we don't get anything back. The paymaster doesn't do anything. That's possible. The paymaster is just to allow you to add some custom logic. Like I said, you could pay in different tokens, etc., etc. Cool. That make sense why if the paymaster exists?
Yeah, I think actually my problem was a fundamental misunderstanding of the Ethereum network and how you actually do anything with smart contracts.
Yeah.
So I think you actually answered in the last like 30 seconds there. Okay, sorry guys. Thank you. Yeah, that was great.
So I'm just going to go to a random transaction, but 100, like, I don't know what this transaction does, but 100%, not 99.9%, 100% of transactions on Ethereum pay miners in Ether. So this transaction, I think this was just transferring ETH or something, but whatever. All these transactions.
Yeah, no, I get all of that. I just wasn't fitting it together right in my head. But
Okay,
no,
cool.
I get it now.
So someone has to pay ETH.
No, I know. I get it now. I get it.
And then, yeah, okay. I think this is a good place to end.
Thanks. It was a good one.
I hope that was enlightening, and see you next week. Peace, brothers.
See you guys next week.
Thanks,